Okay. We have another minute before we start. And
Does DRA have a slide deck that they want to get loaded up?
yeah.
Okay, sounds good. Just want to make sure I'm not missing anything here.
I think I know I'm here. You want time and all that. Okay, well, it is 1:30 and we're going to get started. Maybe some brief introductions, just kind of first start on Zoom, if you can just introduce yourself and who you're with. So Dave Burketta, I guess there's several in that room with you. If you could unmute and introduce yourself.
Hi, right here, David Burketta. So Lyon County, and we have some members of Resource Concepts with us.
Oh, okay. You want to introduce who they are from Resource, or are they going to be anonymous?
No, if you want to go ahead and just go around the table.
Sure. I'm Jill Sutherland.
Okay,
I'm Allie Kramer.
okay.
Chris Bopper with Lyon County.
Keith Alford Hydrology.
All right, thank you. Vidler.
Andrew Ailes, project engineer with Vidler.
Ryan Hurd.
Greg Bushner.
Leanne Brandt.
Okay, great. Phil.
Phil Ritker, Director of Public Works with Douglas County. And I'm in the office here with, nobody, actually, just me.
All right, thank you. Trevor.
Trevor Price with RCI.
Okay. Brent. Can't hear you, Brent.
Sorry about that, guys. Brent Lovett in Silver Springs, just here listening.
Okay, thank you. Bunny.
Good afternoon, Bunny Bishop with the Nevada Division of Water Resources, Water Planning and Drought Resiliency Section.
Great, thank you. Andy.
Yeah, Andy Hummel, Carson City Public Works.
Rick.
Rick Robillard, Deputy Director, Douglas County Public Works.
Okay. Yeah, Lisa. Where'd she go? Okay. Great, thank you. Nilo, is that right?
Yeah, Nilo Bill, a Bureau of Reclamation out of the Lahontan Basin area office.
Okay, great, thank you. Josh?
Hi, Josh Voorhees, also with Reclamation out of Carson City.
Chris? Oh, that's right, there's two Chris's here. Chris Fickley?
Oh, hi, Chris Fakewee Consulting, just listening in.
Lori?
Hi, this is Lori Nicholas. I'm the Deputy Area Manager at the Lahontan Basin Area Office.
Rob?
Robert Martinez, engineer with Bureau of Reclamation.
And we have Chris Gardner?
Hi there, Chris Garner, hydrologist, reclamation.
Okay, I believe, is that everyone on Zoom? We'll go in the room here.
Yes, I just joined Chris Fritzen, Nevada Division of Environmental Protection, Non-Point Source Pollution Branch.
I'm sorry, Chris, I missed you there. And I guess Shannon, you're there too?
Hey, Shannon McDaniel, Resource Concepts Inc., and I'm with
Bruce Scott, Resource Concepts.
Okay, thank you. Am I missing anyone? Can we go in the room? Tim?
Tim Russell with Loomis and Associates.
Sophia Wait, also Associates.
I'm Rishi Parashar from Desert Research Institute.
Greg Reed, Gardnerville Rancho Improvement District.
Daniel Safford.
Eric Morway with USGS. Debbie Nedenrath with CWSD.
Brenda Hunt with CWSD. Nora Nelson, USGS.
Ed James with CWSD.
Jenna Huntington, USGS. And Lindsay March with CWSD.
Great. Well, thank you everyone for attending. I first want to go there. There's a little slight change in the agenda. So I'm going to give a little background on the historic flows along the Carson River. And then Loomis is going to briefly discuss their process of how they're calculating future M&I demands and their procedure as they move forward. Lindsay's just going to give a little general background on historic flows and demands and possible future M&I based on some preliminary work that's been done. The USGS will be talking about their work on the model for the upper and middle Carson. And then DRI is going to be talking about the fine grid modeling, the work that they're doing for the ranchos.
Ed,
Yes.
could all the people on Zoom who have multiple people in rooms go ahead and type your names in for the meeting notes, please?
In the chat.
In the chat.
Yep.
Thank you. So with that, we're going to go ahead and share. I'll begin with mine. So what I want to do is just kind of give an overview of some of the things that we're seeing on the river flow throughout the Carson, some initial work that was done. Next slide. This was you can't probably read this. This was a slide that was presented by Eric Morway about 5 years ago now. Not long.
Since in the publication.
Yeah.
That was just last year.
Yeah, but then when the presentation.
Oh, yeah, 19. That's right.
19, okay, so a while back. And this is showing the meat, it's cut off an arc. I believe this is the Carson City one. And it shows when this was presented, how over from 1940 to present, there was a drop in water flow at that Carson City gauge. Next slide. And then this one, if I'm reading the right one, yeah, this one is actually Fort Churchill. And the Fort Churchill gauge also saw the same kind of reduction there. And this got a lot of people concerned about, is this all occurring because of upstream development? What's going on? Why are we seeing this trends going down? So Max, who used to work in our office here, he actually did this for the Gardnerville gauge and also on the Westford gauge, which is in the upper watershed, which has very little human interaction going on or impacts. Next slide. So this one is at the East Fork of the Gardnerville. And it's hard to tell, but you can also see that there's a trend going down. So we're actually from 1940 to 2021, we are actually seeing less flow coming out of the East Fork. And the next one. And this is on the West Fork. And so again, we're seeing some impacts that are occurring in the upper watershed. That's indicating that over the last, 60 years, we are seeing less flow even coming into the Carson Valley. And so we're seeing some trends of impacts. Next slide. This was a slide done by Loomis for us. And I want to focus on the bottom row. And this also is looking at average change of flow between 1940 to 2018. And you can see at the Woodfords, their calculation was a reduction of almost 8%. At the East Fork gauge, you saw a reduction of about 4%. If you combine the two, based on weighted average and all that, it's almost a 5% reduction that is actually coming from the upper watershed into Carson Valley. And then at the Carson gauge, you can see it's almost a 9%. So there are impacts occurring in Carson Valley on that. And then at the Fort Churchill gauge, you'll see a reduction of almost 3 3/4, and which is less than what you see in the upper watershed. It's easier to produce why we're seeing that change at the Fort Churchill gauge, because we've had a lot of agriculture going out over the last 20 years. And so those changes, but this also confirms what we saw with the USGS. And so we are seeing a trend that not only are we having impacts due to the development and everything else, but we're also getting less flow through Mother Nature coming into this overall watershed, which is something we want to be looking at as we look future and climate change impacts. And then the next slide. And this one here was just a word. This is an old one, doesn't even have the title on it. It was actually East Fork at the Gardenville gauge. And this one here shows a shift. This was done by DRI of what we're seeing when it compared the monthly fractions of flows over the entire year, comparing 1940 to 74 to 75 to 2009. And one thing I want to point out, if you look at March, you can see that more water is coming off now in the last 20 some years versus the earlier years. And then you can see in June, we're seeing the other way. There was actually, so we are also seeing not only less flow coming in Carson, but we're also seeing a shift in the runoff patterns. You don't see much in July and August because there isn't usually much ever flowing in July and August in Carson, but it's just kind of interesting, those trends. And we have a group that's actually going to update the slide to go all the way to, I think, to 2022 and just see if that trend is continuing. But I thought it'd be helpful to get a feel for what we're looking at, and that not only are we dealing with human impacts possibly in this watershed, but we're also dealing with some natural occurring from Mother Nature that may have some overall impacts in future water supply. So that's just a general overview. I don't know if anyone has any questions on that. If you do, you can raise your hand. Okay. So what's going to turn over to Loomis now? They can talk about their process and what they're doing for us. Oh, Phil had a question. Go ahead, Phil.
And that last slide you just showed where the shift to essentially more water flowing or more melt essentially earlier in the season, that is meaningful to the current structure with the Alpine Decree, correct?
Correct. One thing with the Alpine Decree, and the Alpine Decree is very straightforward of this is how it works. It doesn't say this is how it works unless we have climate change or something else. It basically, so as we see more water flowing earlier in the year, that means more water will be flowing down toward Lahontan, because that's when the Lahontan fills, is usually in the winter and springtime. And that could have an impact on future irrigation demands in the upper watershed. And so this is something that we're looking into as we start getting into our analysis. And Lindsay will talk a little bit about that. But also part of our work with the USGS is they're going to be doing some climate what if scenarios with the data once the model gets up and running too, so we can see how climate change may even impact that more in the future. Okay, Tim.
Thanks, Ed. So essentially for the last, 6-8 months, we've been working with Ed and CWSD to coordinate with the various water purveyors up and down the Carson River to gather data. The data that we've been looking to gather is basically well production, usage, and then also trying to understand where their water rights are. Not trying to get into an analysis of their water rights, just understanding how many water rights they have available. Then we have been taking that data, looking out for a 30-year planning horizon to project what the potential future pumping is going to be. And then looking back at the existing production capacity within the different water systems and trying to see if there are limitations on the existing pumping capacity. For example, if we looked at one of the entities and it said right now we're pumping 3,000 gallons a minute, Our actual usage is about 2,000 gallons a minute. In 30 years, our usage is now 3,500 gallons a minute. We would say, oh, it looks like there's a delta of about 500 gallons a minute that is going to need additional capacity. Limitations due to water quality. Is there not the ability to add capacity, pumping capacity due to water quality, and then also water rights. And so we've been gathering all that up. We've got draft reports that Ed's been sending around to the different entities. Some folks have provided feedback, some we're still waiting on. Once we get all that feedback, our plan is to get those over to USGS so that they can take the pumping data now and then look at the pumping data over that planning horizon and see if there's groundwater impacts that we're going to have to potentially mitigate in the future. Then they're going to give that information back to us, and we are going to update our reports with that information. And then if there are groundwater impacts, we'll provide some suggested mitigations that could range from water conservation to interties to there's a lot of different options that are out there. It's not our intention to tell people what to do. It's just to give them options of what could potentially be on the table if pumping continues and there are needs to mitigate in the future. One of the other things that will be in the report is USGS will also run a drought scenario. So the potential mitigation during a drought would most likely be much more extreme. So that's just in a nutshell what we've been doing and where we're at this point.
Quick question.
Sure.
So this reduction in the Carson River flow trend, has there been any study to see the correlation of this reduction with the changes in precipitation pattern, or basically what is Mother Nature doing versus use-driven changes?
Yeah, this is regarding that whole trend. We haven't really gotten to why. We're just seeing the trends. One of the things I like to do is look at the Walker and also on the Truckee to see if we're seeing that same kind of trends occurring. But the data here, and this is all from the stream gauge, is indicating that there's something going on. We just haven't identified what it is. Maybe someone drilled a hole and just taken the water to California we didn't know about or something, but that is the issue. We just don't know why, but it's something that's interesting to see that we are seeing those impacts. And I know when Eric Morley showed those initial ones, there was a lot of concerns of, hey, we're seeing these trends going down in Carson and Fort Churchill, and there were some people who jumped to the conclusion it was all because of all this upstream development from pumping and everything else. And what we're seeing is that it's part of it, but there's also something going on even above that that's Mother Nature's impacting. So, any questions? I know again Loomis is working on the reports. We've gotten several. We've met with others. We're trying to fine tune those and get a better handle on the numbers. And this will really help also with distribution, because that's what the USGS will need to know when they start putting in the model where they're going to pump, because if a well's closer to the river, it may have more impact on the river flows. And so this is all going to be providing into this overall documentation coming into it. But we're still just trying to first get a feel for the growth and what the demands are going to be, kind of a realistic approach. And we're working with every water entity. There's 13 of them to get their feedbacks. And we're hoping to wrap that up probably in the next couple months. I think, Dave Burketta, you got your hand up?
This is Keith. The pattern you're describing of earlier runoff on the Carson River, I don't recall the exact study, but it was early 2000s of taking long records of 60 years or greater and splitting it into 30 years being roughly 70 to 2000 and 70 back to 40. And the same pattern was observed across the entire Western US with a mean shift of about 2 weeks forward or 2 weeks earlier in the year at the time. So yeah, it's real.
Yeah, yeah, thank you. That was done by Dr. Lux, if you know her at DRI. And so again, we're looking at updating that information and just kind of seeing if that trend's continuing. I know when you start bringing up climate change and issues, you get some people that kind of get, well, wait a minute, what's the future? But if you look at the past, we are definitely seeing impacts, and that's, again, as we start dealing with it. Now, again, what's interesting is with the Alpine Decree, it is what it is. And so the Alpine Decree will basically still be part of this. And that's one of the things I wanted to mention. Everything we're doing in these studies follows the Alpine Decree. We're not going to modify or tweak or anything in the Alpine Decree. It's all going to be within the realm. So if the runoff is coming earlier, so be it. That water is going to Lahontan, the farmers upstream. Now, it might drive them to pump more of the supplemental wells. And that's something that we'll be looking into in our analysis.
Question, as you've been talking to the different water purveyors, is it on a voluntary basis? Or, because I assume they're giving you all this information and the data set's going to the model, you want it to be as accurate as possible. So I didn't know if you're getting pushback from some of the purveyors.
No, I think the purveyors have been very helpful, and I think one of the challenges we always have is they have a very detailed understanding of how they operate their systems, and trying to pull that out. And sometimes it takes a couple iterations to make sure we've got the right data.
Gotcha. Okay.
And I have a request. I can hear an echo of everything we're saying. Something's playing through speakers. Can we turn that? It sounds like it's just coming around.
It is. It's Katrina, if you can turn down your computer, please.
Oh, sorry.
That's all right.
Somebody's listening over there.
Well, she's the one who's like taking them.
Taking the notes and
Okay.
everything,
So-
yeah.
Okay, with
Is
that.
that better?
Yeah,
Is
I
that
think that's
fine?
better. Yeah, that's better.
Perfect.
Can I ask a question quickly?
Sure.
And I'm not sure if this is the place to ask it, or if it's later in the piece here, but is the plan, because we're talking about all these challenges, and I'm wondering, is the plan going to address those challenges? You're gonna do the model, but is the actual, like the 30-year plan gonna have recommendations to mitigate any of the challenges? So we're gonna be like,
We're gonna
next
identify,
steps type
there'll
of
be
thing?
things to identify. We're already looking at, with some of the things that's going on in the Humboldt mitigation, there may be some things like, how do you mitigate impacts along the river flows? And we're already starting to identify that, but that's not initially in the plan here. But we will have those as possible recommendations as we move forward. Okay, Lindsay, I'll turn it over to you.
Alright, I'll take it away.
May I just ask one
Sure.
follow-up on the USGS to run a drought scenario? We don't need to get into the details now. Maybe at the end of the meeting, for those on the call that perhaps don't want to listen in, I'd be interested in talking a bit more about what that looks like.
Okay.
I wasn't aware of that.
Surprise! All right.
Awesome. I'll take it away from here now. I presented myself earlier in this meeting, but my name's Lindsay Marsh. I just started with CWSD in November, and I have been working on this project since November with Ed. So I'm going to provide a brief summary of pretty much all that was said, how we're working with Lumos and USGS, and how we're taking that data and what the goal of this plan is. So a little bit of background. So to meet the needs of the watershed in the next 30 years, CWSD has partnered with Lumos, USGS to do a deep dive in water demand, water rights, water production pertaining to the 13 water purveyors in this watershed. Just as a brief overarching summary on what this plan is essentially going to do. So the process, or what we're going through right now, Lumos is gathering all of the information in their reports to estimate that M&I demand for each purveyor. And then all of that data will be going to the USGS to be inserted in the model that they're creating. The USGS will cultivate the model and then run a multitude of scenarios. And then with those results, we'll have a little bit further of an understanding of what we're going to see in the next 30 years, and then provide any mitigation plans based on those. So it's a lot of data collection and review and assessment. And again, this is going to be looking both at the upper watershed and the lower watershed, seeing the effects on the upper to the lower and lower to the upper.
So one thing I forgot to say, we are going to be looking at water demands in Churchill County, but we are just so swamped to trying to get everything in the upper watershed that we have pushed that back. So if you're wondering what's going on in Churchill County, we will be looking at that in the future. It's just, I know a lot of people in the modeling efforts all going to be upstream of Lahontan, but I just don't want people thinking in Churchill County that we forgot about them. We will be including that, but It'll probably occur later this summer when we have more time.
Thanks for getting that in. And just for everybody who doesn't know, these are all the 13 purveyors that we've been working with to get some of this information, and the range of population growth that we're seeing within this watershed is 0.1 to 1.7%-ish. So that's kind of what we're seeing in the next 30 years here. And it's dependent on where at in the watershed we're talking about. So I'll be going over the historical trends in river discharge and some of those preliminary projections that you guys were talking about earlier, starting with Carson Valley. So I was using the Department of Water Resources, their information on historical pumpage in Carson Valley from 2007 to 2020. And then I just separated out into irrigation, MMI, other domestic, and total, which you'll see at the top. I fit a linear trend line at the top just to see where we're going with that. I will mention that the reason why we do see an increase in the Carson Valley is because Carson City is starting to get a lot of their water, or some of their water, from the Carson Valley. So that's why you see a general increase there, but in the other sections, you'll actually start to see a decline over the years. If you look into the preliminary projections, this is what I have gathered from the reports thus far, just to emphasize that this is preliminary data and it will be subject to change when we're doing these draft reports and finalizing them. Okay. Next, we are looking at Eagle Valley, and I did the same thing here as well. Fixed them out in irrigation, MMI, domestic, other, and total. As you can see, we are actually seeing a decline here in Eagle Valley, which makes up for that increase that we saw on those previous slides there. And then existing and future demand preliminary based on the information from the Loomis reports here in Eagle Valley.
We should point out that most of the future growth in Carson City will probably come from the Marlet system. They don't plan to be pumping a lot of additional flows in the future, so that's mostly going to be where the future demands will come from, or supply.
Awesome. Moving right along into Dayton Valley. Same thing here. I'll just let you guys look at it a little bit. We're also seeing decreasing trends there as well, from 2007 to 2021. Okay. And then this is where we saw most of, in the preliminary reports, where most of the growth would be coming from. I know it looks a little bit more severe than others, but it's not that much. But yes, this is the existing and future demand for preliminary in Dayton Valley based on the results. And going into Churchill Valley, you can see that domestic is almost the #1 source of demand there for pumping. What I would like to mention on this one, I only have one slide because most of the growth is going to be coming from domestic wells. They're predicted to increase following the current trends, and the Loomis reports are focusing mostly on municipal and industrial. There's little predicted growth that will come from the service area in Silver Springs, about 75 acre-feet from the numbers that we were talking about earlier this week. And if a new water source comes into the area, they'll have to be considered, and that would obviously produce a lot of growth in Churchill Valley. Other considerations that we're looking at here at CWSD, and things that are going to be a little challenging to put in the model. Changes in agriculture and agricultural management in the next 30 years. We're obviously going to see maybe some differences there or not. Weather trends, consecutive dry years, abundant changes in the seasonal mean, and model accuracy. This is obviously an estimation and they'll have to be revisited frequently to keep it updated over time. We will also be looking at irrigation pumping in Carson Valley and seeing how the Carson River discharge changes within those. This was done by Max, wasn't it?
Yeah.
Max, the man before me, he made this graph, and we can see some correlations between wet and dry years. And so we'll be taking a deeper dive and deeper look into those as well. And plan goals is determine if there's sufficient water rights and infrastructure in place already, understand the effects of future demand and river discharge, and also recommend possible mitigation unrelated to future water demands in the future. So thanks, everyone. Let me know if you have any questions. I'll open it up.
Are there any questions of Lindsay? Again, it's just a general overview. Everything we're talking about is really still very preliminary. As we get more information, Loomis is really focusing on M&I, but we realize that we want to look also at agriculture and other uses in the watershed and look at those trends. And so that's something that Lindsay and I will be diving into the data a lot more in the future on that too, to make sure that we feel comfortable with those trends. And that one graph that Max put together seems to indicate that, I mean, it's very hard in Carson Valley because if it's a dry year, you're gonna have more pumping. If it's a wet year, you're gonna have less pumping. But if you start looking at the highs and lows in those graphs, it does seem to indicate that there may be a trend slightly going up in agricultural production, but we need to dive into that data a lot more. And that's what we're gonna be doing in the next couple of months. Any questions for that?
I may have a quick one for you, Ed, if
Okay.
anyone on the call does. You mentioned that future Carson City growth is going to be supported by the Marlette system. Does that just mean there's going to be less flow from Marlette Lake down to Tahoe? Is that who's going to feel?
Well, basically, they have a right to take, they haven't used all the water, and one of the promises that the Quill plant, because of the Safe Drinking Water Act and changes to it, they were not able to fully utilize all the water they could take from the Marlette system. And so they're upgrading the Quill plant. So in the future, they'll be able to take more of that. And if also you look at the trends, their overall water pumping today is less than they needed 20 years ago. So we have conservation occurring in there. But as they grow and Carson City continues to grow, they will have to take more water, and that'll probably be mostly fed by the Marlette system.
Okay. So they've had unexercised, not fully exercised rights in the Marlette system.
Correct.
Okay.
Yeah. And they're also, I can't remember, Andy might know, either Ash or Kings Canyon, they have those same problems that when there were so many organics in the water and the way they treat it, you have the disinfected byproducts. So they couldn't have that much water in the pipes. I think they had to use that water that came from the Quill plant had to be used by the customers within 12 hours. And so that put a real constraint about how much water they could take. So with the new treatment, they'll be able to do that and provide more flows year round.
Okay.
Good synopsis, Ed.
Oh, okay. Thank you.
Made it easy on Andy.
Okay.
Yeah.
Right. At this point, we'll turn it over to USGS. Who wants to go first?
Yeah, I think we'll tag team it.
Okay.
So I'm Nora and that's Eric. And if you could go to the next slide, we'll just start there. So the USGS has 3 current projects in the Carson River Basin. The first one is the Upper Carson model, or referred to as Carson Valley model, funded by Douglas County. This original model simulation period was from 1980 to 2015, and that was Wes Kitlison's Water for the Season model. We're extending that simulation period to 2020 for the purpose of running these future scenarios out to 2050 that are being prepared by Lumos. The Upper Carson model takes inflows from pure
Louder, please.
Yeah, you have to be louder.
Okay. Yeah. Okay. So the Upper Carson model uses inflows from PRMS and then feeds it into a couple of ModSim ModFlow model. And I guess I already mentioned those. The scenarios are being provided by Lumos. The second project that USGS has in the Carson River Basin is the Middle Carson model, which is funded by CWSD. The original model had a simulation period of 2000 to 2010, and we're expanding that forwards and backwards in time to have the same simulation period as the Upper Carson model, because for the future scenarios, by Lumos to see the combined impacts from the upper model and the middle model, we actually run the Upper Carson model for those management scenarios, and then
the river outflows from that model then are used as the inflows to the Middle Carson model, so you can see the combined impacts. And then we have a third project in the Carson, which is the Carson capture model, which won't really begin until we have finalized the upper and middle Carson models, because those are necessary to do the capture modeling parts. But the capture model project will have a historical capture component and a predictive capture component. And then there will also be a capture query tool similar to the one that was built for the Humboldt.
And I'll take this slide. So this is kind of summarizing where we're at with the Upper Carson model, which is again building upon the work that Wes published in 2021. We are going, and it's done, we've already extended the East Fork and West Fork watershed models. Those are the output from those models serve as the inflows to the Carson Valley model. And then so with the Carson Valley model, the ModSim ModFlow model, there's a couple of big packages in there that are important for capturing the hydrology there. And so we're actively trying to update the data sets that support those packages, such as the streamflow routing package, for example. That's what deals with all the diversions in Carson Valley. And that has a close relationship with ModSim, which is doing all the switching on and off of diversions at model runtime based on the flows in the river, or based on flows in different parts of the system. And so Wes is no longer with the USGS, and we had Kara was working on this model. Kara has departed for DRI, and so we're just in the process of getting our feet under us again for extending the Carson Valley model. And I'm happy to address any questions either now or we only have a few more slides, so yeah.
And then, yes, just a quick summary of the most recent things that we've been working on with the Middle Carson model. So the lake package has been updated to the ModFlow 6 format, and we've incorporated monthly diversion data provided by Ed in the SFR package. And the last two packages we're working on are the unsaturated flow package and the well package. And so the well package is going to simulate domestic municipal irrigation, and then this other pumping. And you can go to the next slide. I was just going to, so the original Middle Carson model didn't incorporate domestic pumping, so we've added that. We got the well point locations from the NDWR pumping geodatabase. And I apologize for this map with very little context on it, but this is the Middle Carson Basin. And so the three sections are Eagle, Dayton, and Churchill Valleys. Some of those wells are not in the active model domain, but this figure is just so you get a sense of the well completion dates and sort of the distribution, like over time, of where domestic wells are located in the middle. So currently, the domestic wells are set up to turn on based on their completion date. And then the total amount of domestic pumping for each year is constrained by the Maurer and NDWR data for total domestic pumping in each sub-basin. And then the monthly pumping will be distributed based on an assumption that is the same as what is built into the Carson Valley model. So you can go to the next slide. So we're using
two different strategies for implementing domestic irrigation and other pumping. Pumpage inventory data from NDWR was available for 2007 to 2020. So that's where we've got those rates. Prior to 2007, where we don't have the NDWR pumpage inventory data, we are basing pumping rates based off Mauer's estimates for the basin by manner of use, and assuming a monthly distribution for those as well, same as Carson Valley. And then, so for each year, the wells that have a certain method of use, that total estimate is distributed among those wells, if I didn't trip over my words too much.
So maybe question if I could.
Yeah.
So when you see it pumping is down, like in 80s, is that because you say it was a wet year and they weren't pumping as much, or domestic wells, or what's that graph, the gray line showing?
The gray line is showing your total irrigation estimates for all of Middle Carson Valley based on Mauer.
Oh, okay, that's
2009
irrigation,
report.
sorry, okay.
Yeah, so the gray is irrigation and the blue is domestic. And those are annual rates in acre feet.
And the domestic, what is your assumption for domestic well? How much per year?
Well, that would be one strategy, is to like assume a rate for each well, but we thought it would be better to take the entire basin-wide estimate of pumpage and then divide that by the number of domestic wells that are pumping and assign that value to those pumping wells instead.
Is the
Does
blue
that-
line, is that what Doug published?
Yes.
So there's
So-
two ways to get at it. We
Right.
could get at it by having some estimate of the number of domestic wells by year, and then apply what you're suggesting if we assume some rate.
Right.
Another way, and the way that we're currently thinking, is to take Doug's published estimates, because we found in our network is the Excel file that that blue line came from, and use that to guide the pumping we're going to simulate in the model
For domestic wells.
for only the domestic wells.
Okay, because I know that, you're allowed 2 acre feet per dwelling unit under Nevada water law. I know that the state engineer assumes 1 acre foot per domestic well. And what we're seeing results probably in Lyon and, most areas, most people are using probably less than half an acre foot. So I'm just curious how he came up with his number for that line. Do you know?
I don't know offhand.
Okay,
We could
With
get
what?
up
Okay.
and
It's
get
documented.
back to you.
okay, I was just curious.
I did notice that we have a hand raised. for
Okay.
Devika.
Go ahead, David.
Keith Alford, I have a question. On the domestic pumping, if the numbers from Doug, I would bet anything, he assumed 1 acre foot per year. So you still might want to come back and revisit wells. But right now you have domestic wells from the 1940s. So when you look at the domestic wells, how long do you assume it exists before a replacement well is drilled?
Yeah, I think there's lots of questions in that same vein. Not only that, but then we have to account for when domestic wells are, put on.
This wasn't an open-ended question. This was saying, right now, you have something you've compiled. Did you assume that those wells existed from when they were drilled to today? Or do you have an extinction, a time frame where they operate for 20 or 30 years and then you extinguish them?
They do not currently have an extinction date.
Okay, fine. We assume they operate forever. That's all.
Thank you.
I assume the house would need water, so unless they get to the municipality, they'll either re-drill a well or something like that too, so. Okay,
Anyone else?
Have
I
another one?
think, there might be another slide or two. Yes, and then, so we have annual pumping estimates for 1980 to 95, and then NDWR and CWSD provided monthly pumping for municipal wells. I think that's it for that slide. I can't remember if we have another one. Oh, that's it.
Just you guys.
Okay. All right. So we'll stop sharing here at this point. And Dan, do you have a PowerPoint?
I do.
So
yeah.
while Dan is getting his PowerPoint loaded up, we wanted to let everyone know that on March 5th and 6th, we have the Carson River Coalition Forum. And there'll be flyers going out, but if you're interested, there's a lot of good discussions on various topics. Oh, there it is. Look at that. How about that? So if you're interested, let us know. Contact our office and we will provide lunch and we have snacks.
The GRGID
And
folder.
there's just something, again, opportunity there, but we wanted you to be aware of that forum coming up.
CWSD. Yeah, that one right there.
And I'll put up the
Yeah.
flyer again at the end of this, so if you guys are interested, you can look at it a little bit longer, but we'll keep this moving with ERI. Oh, I need to show this. So hard when the top of the screen was cut off. Okay, there you go.
Yeah, that works. All right, thanks, everyone. Good to be here. Ed asked me to keep this at 20 minutes or less, so I'll try to do that.
Okay.
I've got a few slides in here, so we'll skip through if we need to. Again, my name's Dan Safner. I'm with DRI. I'm here with Rishi Parashar. We've been working closely with Gardnerville Ranchos for the last couple of years, doing a groundwater sustainability assessment there. So that's what we're going to be talking about today. For the most part, I'll be going over kind of the hydrogeologic characterization that we've been doing, with the ultimate goal of putting together a mod flow model. That's really in its early stage. So yeah, today we'll just talk about kind of the hydrogeologic characterization. So this view that you're seeing here on this slide, I'm sure everyone here is fairly familiar with it, looking down into Carson Valley. We are looking east, so we're seeing the snowy Pine Nut Mountains on the east side of the Carson Valley. So it might be kind of hard to see from the seats, but you can see the darker blob on the valley floor. That is Gardnerville Ranchos. So I was skiing at Heavenly a few weeks ago and took that shot, which I thought was a good way to
Nice.
start off with a nice pretty picture. Yeah, you want that. I figured
So
want
great, you
that.
call yourself a great blob, is that how you're?
No, I mean, it's a beautiful
most
blob.
days.
When you can see the picture closely, it's a beautiful blob. And then just for reference, so you can see Gardnerville is the next blob to the left. So that's to the north of Gardnerville Ranchos. So you can go ahead to the next slide. Just for some spatial context here, so everyone is aware exactly where Gardnerville Ranchos is located. It's essentially in the center of Carson Valley. It's at the southern extent of the valley floor, right between the West Fork and East Forks of the Carson River. Again, I mentioned Sierra Nevada to the west and the Pine Nut Mountains to the, bounding the east side of the valley. You can go to the next slide.
Louder, please.
Oh.
It doesn't go very much farther.
Okay.
You want to do-
Sure. Yeah, let's-
Can you put that in presentation
Usually I'm
mode
asked to
or
be quiet.
it's hard to see it?
It's hard to see.
It's hard to like see the maps thing.
All right, we're back. Is that better? Can you hear me okay?
Yes, thank you.
Okay, great. Okay, we can go to the next slide. So this is a busy surface geology map on the right side of the page here, but just want to kind of set the context of the geologic and geomorphic environment of essentially what we're looking at here is the extent of really the southern Carson Valley area. You can see that there are some circles on the bottom of that geology map. So that's showing the extent of the well network specific to Gardnerville Ranchos. And I highlighted on this map just to show that you can see that the community sits on top of a geologic unit that is fairly, it stands out. It's different from the rest of the valley. So it's labeled as QICR. It's mapped as an alluvial fan deposit. We've done some drilling in this project to take a deeper look to really assess the depositional environments, the stratigraphy that's going through this, what is now a river terrace. So the East Fork and West Fork have essentially eroded the surrounding sediment, redistributing the sediment onto the valley floor, leaving behind this river terrace that exists today. So it sits about 10 meters above the rest of the valley floor. So one of the key questions that we're looking to answer here with, we'll get into all the testing that we did, the aquifer testing that was conducted, is to really determine how hydraulically connected this river terrace is to the valley floor. So we can, or one more thing I'll mention here is just to note on the eastern half of that orange river terrace that's shown here, you can see that there are a lot of black lines. Those are mapped faults. That's another key component of our study, is to characterize the role that those faults are playing with respect to groundwater flow in the area. So you can go to the next slide. Just a brief kind of history of pumping in Gardnerville Ranchos, groundwater pumping. So water is sourced exclusively from groundwater in the Gardnerville Ranchos community. They have 7 supply wells that are being shown by the orange circles on the map here. So this is just now a zoom in of the geology map, and now you can actually see the footprint of the community underneath that map. The supply wells essentially line the perimeter of that river terrace that I was describing. The eastern wells, the supply wells that are on the northeast side, are in the meander belts or fluvial deposits. There are some wells on the western side that are at the boundary of the terrace deposits that go through fluvial and alluvial deposits with depth. There's one well that's more situated, well 5, so at the southwest is a little bit more directly in the river terrace deposits. So 7 supply wells in total. All of the blue circles are showing locations of monitoring wells. So looking over the past about 15 years on the plot on the left, you can see certainly interannual variability in the total pumpage from all of the supply wells. But overall, you can see there certainly is a decreasing trend from 2009 onward. That's related to many different things, including water conservation practices that have been put into place by the community, as well as climate variables as well. The population that's served by the water system is about 11,000 people. So we go to the next slide. So the primary question that's being asked that we are working towards answering is essentially, how will groundwater levels in the Ranchos area respond to projected changes in temperature and population growth within the community itself? So we had essentially three project tasks that we have been working on for the past couple of years. So again, today I'll be really talking about task 1 and 2. Which task 1 is basically the field component data collection. And those data have gone into the development of a kind of a refined hydrogeologic framework for the area, which will then serve as the basis for eventually a mod flow model to run some predictive scenarios. So just to highlight the locations where we did some drilling in 2022. So the 5 locations that have the red squares around them show the locations of the boreholes that were drilled, each of them to approximately 200-foot depth. The continuous core was retrieved from each of those holes and were logged for texture, moisture, color, and other characteristics. So we really focused on the northeast side to get a better understanding of the geology on that side of the river terrace. We had fairly good coverage on the west side, you could see with those existing monitoring wells, and a decent record of the geology there. So focused on the northeast side, and also strategically placed those wells with respect to the location relative to, again, I'll bring up the faults. So you can see that there are the lineaments that are running in the north-south direction, placing those wells between some of those faults and adjacent to the supply wells to characterize the hydraulic properties and the roles of those faults. Each of the so the boreholes were then completed with monitoring wells, which range in depth from 120 to 200 feet, and pressure transducers are now in all of these wells. So continuous water level monitoring is ongoing in all of these locations. The aquifer testing that was conducted. So just a quick summary. So again, 7 supply wells. So we stressed each of those wells individually and monitored the drawdown extent throughout the well network using the pressure transducers that we have in place to monitor the extent of the cone of depression. For anyone in the room or online that maybe isn't extremely familiar with aquifer testing, just I put a few schematics in here just to highlight kind of the key principle of how this works. So when you pump from a well, you create this cone of depression, which you're ultimately just reducing the pressure within the aquifer itself. So that change in pressure head or hydraulic head expands away radially from the well, from the supply well that's being pumped. So the shape, the magnitude, the timing at which that cone of depression forms tells us about the hydraulic properties that we're looking to really getting at with these tests. So working towards getting hydraulic properties, so hydraulic conductivity, storage coefficients, connection between the different geologic units that we've described briefly, and connections between the deeper confined aquifer, shallow unconfined aquifer, boundary conditions such as the faults and some of the surface water features that are flowing nearby. So 7 wells were tested. The discharge rates ranged from 225 to 1,300 gallons per minute, depending on the well, depending on the test. And the duration was from 4 to 7 consecutive days of pumping to stress the aquifer to the maximum degree that we could without disturbing Greg's operations for too long. Next slide. Was happy to see that Keith Halford was chiming in. Keith, love Series C tool, use it all the time. So here you go. That's for you. So this is just to highlight kind of the data processing and analysis. Yeah, so the Series C. Oh, go ahead if we have a question. Yeah, sure.
Go ahead, Chris.
Yeah, I'm sorry. I was going to wait till the end, maybe you'll get to it, but since you called me out, I'm wondering. I didn't see on your proposal as far as what you were looking at, as if what kind of capture component these wells might have on surface water, and if that's work is being coordinated with the USGS in their capture modeling effort that Nora spoke about earlier.
So there's not really a capture component to this. That's not one of the objectives of this model. Certainly, I think there would be great conversations to have with the USGS folks on considering what we find here. So the next few slides, I am going to show basically the spatial extent of the cone of depression that formed for each of these tests. So you'll get a sense for especially on the east side, because it's directly adjacent to the East Fork. But there's, it's a good question in terms of how much capture there actually is, but I think I'll probably get into more detail and answer that with a little more depth in the coming slides, if that's all right.
Sure, thanks.
Great. Just to sum up this slide here, just on the data processing and analysis side, so we did use the Series C tool to back out any background trends, natural or environmental fluctuations in water levels, so that any changes that we saw during testing could be therefore attributed to pumping that was taking place rather than any seasonal or any recent infiltration effects of any precipitation that may have occurred. So we back all of that out and then use the drawdown, the modeled drawdown data as inputs into the Octasolve program to estimate aquifer hydraulic properties and flow conditions. Thank you. The next slide.
There was another hand that went up.
Yeah, Dave.
Miketa?
This is Keith Halford helping out with Chris's question. So even if they don't directly try to look at capture on Carson River, by better defining the transmissivity, which greatly affects estimates of capture, when you feed that in and constrain the model to what they've estimated, you will have much less uncertainty on the capture estimated with models that are, tied to these aquifer test results.
Yeah, good point, Keith. And I just hope that everybody's sharing information with the GS so that we have the best of what's available going into the capture model. And I mean, it seems like with particularly those east-sized wells, the Carson River could be a constant head boundary and something that should be looked at.
Yeah, so something that I'll just add here is that the depth to water in these wells that are close to the East Fork here, so wells 1, 2, monitoring well 5, well 4, the depth to water is pretty great. So the depth to water there ranges from about 50 to 70, 75 feet below the land surface there. We didn't set up any monitoring stations in the East Fork to see if there was any change in flow. That's again kind of beyond what the scope of what we were doing here. Yeah, but just simply looking at kind of stage versus groundwater elevation is something to consider there.
And we did briefly look at the isotopic signatures. It was not very conclusive there.
Okay.
And still more work to do with the isotope data. So moving on here, this is just kind of a big picture, essentially one of the key take homes from the aquifer testing. Again, I will go through some of the individual tests, but there are 4 distinct what we're calling hydrogeologic blocks that are bound by low permeability faults that are, again, extending in the north-south direction. I will show the cones of depression that form during each of the tests within those blocks that illustrate that that is the case. There's a high transmissivity in the north-south direction in each of the blocks and much lower transmissivity in the east-west direction. So, we look at these maps, we look at these faults, right? You see these single lineaments, which can be the case at times, but of course in the subsurface it gets a little more complicated, complex, more interconnectedness of faults and fractures that can be contributing to kind of that northern preferential flow and north-south direction of high transmissivity. So we can go to the next slide. So the west, or the map on the left is showing the drawdown contours or the cone of depression from the well 2 test. So this is not labeled anymore, but this is what we're calling the east hydrogeologic block. You can see the contours are labeled in the legend on the left side. So the drawdown that was produced at this well, the maximum drawdown was about 90 feet with the amount of drawdown decreasing as we move to the south. So we did see drawdown as far south as that monitoring well number 3, where there was about a foot of definitive drawdown there. So what stands out here is that the cone of depression really does propagate to the south, but not outside of that geologic block into moving to the west or the east. So well 4, for example, in the east block showed no drawdown. Well 8 to the northwest, MW2 to the west, no detected drawdown in those wells. Again, suggests that those faults are acting as at least partial barriers to flow at this point. Just thinking about this test, we'll see another test that some drawdown does, or the pressure does propagate beyond those faults, especially the one that runs through the center of the page there. So there's just a little schematic that helps illustrate kind of what that looks like in cross-sectional view. So the map on the right side of the page, so this was a test that was conducted at well 4, where all of the drawdown, at least within the network that we are monitoring from, all the drawdown is limited to that far east block. We didn't see any drawdown at any of the adjacent monitoring wells. That can be attributed to several different things, one of which that well has a very low specific capacity. So it doesn't take much of a pumping rate to draw that well down pretty far. So we could only stress that at about 225 GPM. That was our lowest rate that was achieved. And so just that low rate in general, you're not going to expect that cone of depression to propagate very far radially. But there is also the fault that is shown that runs kind of northeast, southwest to the west of well 4. That again, we from all the tests conducted on that side of the study area, that fault is likely a barrier to flow because we see very little drawdown at well 4 from any pumping at the wells that are to the north of that.
Is there like an escarpment right there too?
Oh yeah.
I'm just,
Yeah, absolutely. So yeah, and there's a really pronounced, especially on that eastern side, that these faults, I mean, they stand out as soon as you're driving by. There's 10, 15 foot of an offset, so pretty apparent at the land surface. Just a few more tests here. So well 8, this was in the central block. Again, seeing drawdown propagate pretty far to the south. So this was almost 10,000 feet to the south at well 7. We saw 0.2 of a foot of drawdown. And then again, just to illustrate, very little drawdown was detected outside of that block that we were pumping from. So monitoring well 1 to the west, you can see that there is a drawdown contour that does make its way over there. We saw 0.2 of a foot of drawdown over there, which suggests one of two things: that the west, what we're calling the west fault, is not a complete flow barrier, or that it just doesn't propagate vertically all the way through the fluvial deposits that are between the supply well and that monitoring well. Because well 6, if you know, that's a deep supply well, and we saw no drawdown there. So kind of helps put together that conceptual model that with having those two wells that are pretty close to the pumping well, seeing little to no drawdown. And then again to the east, no detected drawdown east of the pumping well. And then finally, I think this is my last one anyway, then I'll move on. The map on the right side of the page, we stressed well 6, and that basically corroborates that the west fault, we saw some bleed through effect there, that there was some drawdown that was delayed a couple days after pumping, which shows good that we pumped for several days at each of these wells, because we did eventually see 0.4, I think is what it shows. 0.4 of a foot of drawdown at MW2. And yeah, that cone of depression really extends quite far to the south. And a point that I'll make on the next slide, I believe, yeah, so this one is showing that basically kind of confirming the theory of a layered aquifer system here. So these boreholes that we installed during this project were targeting the shallow aquifer, the shallow unconfined aquifer, whereas the supply wells are being supplied from a deeper confined aquifer. And we see some evidence of this layered aquifer system in the drawdown data. Looking at well 2, again, 90 feet of drawdown at well 2. If you move to the southeast, you see monitoring well 5 had only 4 feet. Well 1, even farther away, had a greater magnitude of drawdown than well 5. So typically, again, like that cone of depression I described earlier is going to reduce in magnitude as you move away from the supply, from the pumping well. But that's not what you're seeing here. So that is representative of, there's a little schematic that shows, okay, that monitoring well 5 is certainly screened in a shallower aquifer unit than the deeper pumped aquifer. And we see that in different locations. This is just one example. We saw that in the west side as well. Next slide. Getting into the hydraulic conductivity and storage coefficients that were estimated from the aquifer testing. So keep in mind that the plots that we're looking at here, these are the log of hydraulic conductivity values, but this helps in just kind of looking at relative values, comparing each of these hydrogeologic blocks. Overall, hydraulic conductivity and specific storage decrease as you move from west to east. There's certainly a lot that is coming into play with this, but this, for the most part, is coming back to two things. One being lithology. So this pretty rudimentary, rough geologic model that we have on the right side of the page here takes in, it doesn't provide too much spatial context other than the north, south, east, west, but this is the extent of our planned model domain. So we use the lithology from all of the wells that exist in Gardnerville Ranchos, as well as borehole driller logs from DWR to put this together. But one thing that is clear is that the clay content increases as you move to the east. So in that western hydrogeologic block, there's very little clay. It's really coarse deposits, so sands and gravels with cobbles, trace clays, as is written out there. So those coarse materials have significantly higher hydraulic conductivity than the rest of the blocks to the east that do have a greater clay content. Go on to the next slide. And finally, just kind of zooming out a little bit. So this is still kind of thinking about the aquifer hydraulic properties, but now also taking into consideration other wells in the area. So this map on the right side of the page is showing really the extent of the southern half of the Carson Valley, looking at other wells that have specific capacity data that we can use to estimate hydraulic conductivity. So the table on, well, I guess I'll just say that a few things spatially that stand out with that map, right, is as you move to the north, move into the basin, you can see that generally there is a trend that the hydraulic conductivity is increasing. You get out to the margins of the valley, and those bubbles are smaller, so hydraulic conductivity is lower, and that's fairly consistent when we do zoom into Gardnerville Ranchos. We saw a very similar sort of spatial relationship there. And the table on the left, I won't go into detail there, but the different hydrostratigraphic units that we will be considering including in the model. So geologic units that have similar hydraulic properties based on both our tests and these other data sets. So we'll go to the next slide. And this is my last slide. Again, this is early stages here, but just to outline what the plan is here. We have, I think really this is one of the key things is, I'm happy that we're here today to get the chance to sit down with everyone in the room, but also while we were happy that Kara is at DRI now, but we were unhappy because I was talking with Kara a lot about the work that was being done at the USGS with updating that 2021 model. So I look forward to continuing those conversations, probably with the 3 or 4 of you in the room, to ensure that what we are working on in Gardnerville Ranchos can, to the degree possible, be synced up and considering what's been done in that Kit Laston 2021 model or 2021 publication. So we've certainly at this point taken what I'll say is maybe not a deep dive, but started diving into some of the files that you all have. That is awesome that's all available to help kind of inform, our boundary conditions, thinking about initial conditions, hydraulic heads, certainly also considering hydraulic properties that are included in that model as well. That being said, here's just a general breakdown of kind of the planned different model iterations, I guess. So steady state model, so calibrating to pre-development conditions, so targeting water levels 1965, transient, so getting the initial conditions, initial water levels to build a transient model that will be calibrated to pumping conditions during our aquifer testing, as well as historical pumping. And then finally, a predictive model which is planned to have a 20-year simulation, so from 2024 to 43, with varying temperature increases and the impacts on the water balance that come out of that, which that's really what we've spent a lot of time talking with Kara about is how we can take into consideration kind of the way that this is spelled out in the recent USGS efforts to just to basically be sure that we're taking that into consideration. So looking at temperature increases above historical average of an increase of 2 degrees Fahrenheit and 4 degrees Fahrenheit, those are the numbers that we're considering right now. There's a little asterisk at the end of that just to illustrate that those numbers are not final. And that's an increase of 2 degrees Fahrenheit by 2043. And then for the next simulation, looking at 2043, an increase of 4 degrees Fahrenheit. And then water demand scenarios, so consistent with the water master plan that Loomis is working on for Gardnerville Ranchos. So they have their population projections, water demand projections. So the 1.5% annual increase comes from that effort. That, however, assumes no water conservation measures. So that's kind of a worst case scenario. Then there's another simulation that we'll consider running a 0.2%. There's an asterisk on that one. That number might change as well. Plenty of conversations to still be had about that, but that's expected to be a little more representative of a realistic annual increase. And I think that's my last slide. Yeah, so that's all. Probably went over the 20 minutes. But
that's right. No.
Yeah, if anyone has questions, happy to answer them.
On your growth projections and are you starting off with the lower production now and having that increase, or what? Because you've shown on another slide that demands are going down and then you're going to show it go up. So
can we pull that? Can we pull that? I think it was like the 4th slide maybe. Yeah. So Greg can certainly speak to this better than I can, but I'll do my best with, this plot, perfect. So you can see that since 2017, the total annual pumpage has been well below that orange line, which the orange line is the average over this time span here. So one factor that definitely contributes to the lower pumpage here is that it was 2017, right, that began metering. 2018 was the
The 2018 was the first year that we were fully metered.
So that's kind of the new normal.
Right.
The new normal of total pumpage in ranchos. So that we would take the average, the starting point would be the average of that 2018 to 2023.
Okay.
And that would be the starting point and then build off of that.
Okay.
Yeah.
Even though in the past, we pump more water than that, right? So
well, yeah,
right.
But we had to pick a point to start with, and it didn't make any sense to pick a point that was maximum of where we used to be, because it's going to be a long time before we can get back there, because we have, we've seen an increase of 150 homes since 2017 and a decrease in water production. All right. So for us to go back to those high numbers were unrealistic, because that was during unmetered. We had portions of the district that were unmetered. We finally got fully metered in the entire system in the middle of 17. So 2018 was the first full year that we were fully metered in the entire system.
Okay.
Also, I'll briefly add, the way that we are stressing the model is not by a gross annual pumping number. We are doing it week by week.
Oh, okay.
So we have 52 numbers for the whole year, and those vary quite a bit, as you can imagine. Very high numbers in July and August, and low numbers in November and December. So we are taking that into account as we are stressing the model.
Oh, good.
And I think that's a good point, because we go in the wintertime, we pump about 600,000 gallons a day. Okay. And then in the summertime, July, August, September, we will get to 6 million a day. Okay. So a factor of 10. So you can stress the aquifer and know what the results are going to be without relying on total pumpage for the year. And that's what they're working on.
Okay. And that ties into stuff that you guys are working on too, that will provide to US. So the circle is complete here.
Yeah.
Okay. So are there any questions from anyone out on Zoom land or here in the office? You may have. I do want to say that, so, we're going to have periodic meetings in the future again. Probably when the USGS starts running their model results, we'll have another meeting at that point to start looking at impacts and what we're seeing through the area. And then hopefully after we get that data, we'll be passing on to Loomis. Loomis will start putting their report together, and then we'll probably have another meeting at that time. Because of some exchanges, since DRI is taking USGS employees, we are, there's going to be a little delay in some of the work. And so we're looking at a time extension with the USGS. And then we're also looking at a time extension with our grant funding entity. So we probably will not be wrapping this up until late fall, early spring of 2025 now. So just giving everyone a heads up on that. Also, I may be contacting all the water purveyors and talking about giving an update to your boards at that time, just kind of where we are today, maybe in the next couple months, taking everything that was consolidated here and consolidated into a shorter presentation, but let everyone know kind of what's happening with this process.
Lindsay, do you want to put that thing back on?
When you say late fall, you mean 2024, right? Late
2025 is when we're going to.
You said late fall or early spring 2025. So are you talking 25, 26?
Yes, sorry.
Okay.
Yeah, so probably the September or later in 2025. And again, if you're interested in the forum, Lindsay will give a talk on what we've talked here, but there's a lot of other topics that'll also be covered at this
We have
forum.
a very sneak peek for those who are in the room of who's talking.
Okay.
It could change a little bit, but
you wanna-
I'll pass that around.
So go ahead.
Oh, Shannon
Question. Yeah.
has a question.
Go ahead.
Hi, this is Bruce Scott, and Ed, one thing I think that particularly the Carson Water Subconservancy District might be considering looking into is the concept of utilizing the data, obviously, that's being generated, but more beginning to look at management scenarios for the Carson River. We have an interesting situation where we don't have upstream storage, we have downstream storage. And Walker and the Truckee both have upstream storage. The lower White River flow system is all groundwater. We have highly variable flows in the Carson River, and the management potential of how do we deal with that, both upstream and downstream, I think is really going to be important, because you have, in a wet year with Lahontan full, you probably have more evaporation in Lahontan Reservoir than you begin to use upstream in some of the groundwater pumping, but in a dry year, you have a tremendous deficit. And as Keith Halford mentioned earlier, the groundwater tables tend to bounce, and dry periods they go down, but they seem to be coming back up. And we have effectively within the river basin, we have a number of groundwater reservoirs that might be part of a management system that could be a way to help mitigate, because we've got some large economies that are dependent on groundwater pumping in the basin, and we have to find a way to try to balance and look at all of the interests, I think, in the whole system. So the management side is something that I think could be looked at in parallel, or begin to be looked at in parallel. It's real hard to do anything with the water law, but it's conceivable that some kind of a
management tool from the Division of Water Resources under orders or policies, there might be some ways that we could begin to establish mechanisms for the water purveyors on the Carson River to be able to plan and execute how to do water development, water management, well management, and that sort of thing.
Well, I appreciate that, Bruce. We'll probably be looking at that. One of the main things we're going to be doing now is just what the magnitudes is. And that's what this study will hopefully get us, because right now there are numbers all over the place, and this would really help us better define what are we really talking about in the future. And once we have those numbers, then we have a better understanding of what kind of mitigation or management plans we want to pursue in the future. So we are definitely looking at that, Bruce. But this is really going to be a good starting point of what are we really talking about in the magnitudes. Chris, I see your hand is up.
Thanks, Ed. This is Chris Fakely. I think it may be related to kind of what Bruce is saying, and we talked a little bit about this yesterday. I was just curious if, sources of recharge or return to these groundwater systems are being contemplated in the modeling effort, which, if this is going to come out to future analysis of capture conflict, we just want to see how we're introducing some of those sources, whether permitted or, septic systems or things of that nature.
Yes, I don't know. One of the things we had talked about is with there's 1,300 domestic or septic systems in Silver Springs area, and they are recharging. Is that in this modeling effort, or is that something in the future we'll be considering with your capture model?
It's not in the published model, and it's not in the middle Carson model that's being updated. Though we certainly, since we're still developing, this would be a great time to revisit that. But other sources of recharge, such as mountain front recharge, flows coming in from BC Canyon, the ribs out near Dayton, those are in the model. So,
okay.
Yeah.
What about ag?
Recharge from ag is in the model, yes.
But I think you're also, so you do have the RIBs, the rapid infiltration basins, and some of those, and then Carson City has a Brunswick Reservoir that leaks.
That's in the model.
Okay. Okay. Well, it just
what are you talking about?
What am I linking?
That's a good thing.
Yep. So those are things that will be considered when you start looking at a capture model. It's captured, but it's also being recharged, and then of course other sources. So all those will be incorporated. I think we have another Chris. Hannah, you have your hands up.
Yeah, just another thought, and I should have mentioned it earlier when there was a discussion about future use down around Silver Springs, and I would just encourage the folks working on that to reach out to, I think Chris Fakely can correct me on the name. I think it's Northern Nevada Industrial Park that's filed change apps on Carson River surface water, and they also hold a fair amount of groundwater rights in that basin. And I think they have plans to develop, significant amounts of groundwater and using converted surface water rights for development of an industrial park around Silver Springs. So just keep that in mind.
We did talk about that yesterday, Chris, and I think at this point, since it's really not well defined, we're not going to include it, but will be identified as a new source if it does go through. But there's just so many questions with that project that we figure it's easier just to go with what we have today. So.
Okay. Yeah, I didn't know you talked about it yesterday. I just wanted to toss that out there.
Okay. Was there another hand up I saw? Okay. All righty. Well, I hope you found this useful. This is what's moving forward. And if you do have questions or comments, please let us know. as we start moving forward, because again, as we start developing this, we do have the draft reports by Loomis. We are meeting with everyone. There are some rewrites going through. And then once those are available, we'll have a much better understanding of what the demands and provide them to USGS. And then we can talk about this capture model and also the recharge and other things too, when may be appropriate to look at those scenarios. Because our budget is limited, so. So, all right, well, that's all we have. Well, thank everyone. I appreciate your time and have a great day. Yeah. So,
Time back.
here you go. Thank you.
Thanks, everyone.
Thank you.